In this lecture, I'm going to provide you with a brief history of data science. Just like in the last lecture, we looked at several key moments in the history of artificial intelligence. In this lecture, we will do the same thing, but for data science. Just as with the last lecture, you need to remember the particular historical period, the years, the name that's attached to those years, and the main takeaways, which we're going to look at in just a moment. The period from the 1960s to 1980s is known as the Foundations period. From the 1980s to the 1990s, we have the age of databases. From the 1990s to the aughts, we have the age of the internet. This will line up with the Renaissance period of artificial intelligence and the era of big data. From the aughts to the 2010s, we have the emergence of data science. And from the 2010s to the present, we have current trends. Before we launch into the history of data science, I just wanted to briefly go over the DIKW pyramid. And DIKW stands for Data, Information, Knowledge, and Wisdom. I think that this is really a foundational concept when it comes to understanding data analytics and data science. Very briefly, data is facts, unstructured, raw facts. It is only when we have a collection of facts or data that patterns begin to emerge. And when those patterns emerge, we get information. So for example, the number 72 on its own is really unhelpful. There's no context. We don't know what that is attached to. But the numbers 72, 74, 76, 79, 79, 80, 81, 81.5, 82, those numbers together demonstrate a pattern. And what we see if we plot those numbers is a rise, starting with 72, going all the way to 81.5. So we know that there is an increase. With more data, with more facts, such as April, June, July, now a pattern starts to emerge. We get more context, we get information, we see, oh, well, this is the change of the seasons, right? We're moving from spring into summer, and the average daily temperature is getting warmer, for example. When we have information, we can do things. And doing things with information is knowledge. Again, we have facts. We arrange those facts into patterns. Patterns and trends inform us. And when we have information, we can do things. We can demonstrate knowledge. And so knowledge is doing things with information. Finally, wisdom is the application of knowledge and experience to make good decisions. Now that we have all of that built together, it's going to be easier for us to understand what data science is. Data science is using different processes, techniques, and tools to extract knowledge from data. So we aggregate data, we mine that data for patterns, for insights. Once we have that information, we can then make good decisions. We can do things with that information. And so that's what data science is. It's crunching numbers, it's crunching data, looking for patterns, and then once we have that information, those patterns, we can do things with that information. The Foundations period in the history of data science, again, this takes place from the 1960s to the 1980s. The term data science is introduced during this period. And as I said just a moment ago, data science is the use of processes and technology to extract knowledge from data. During this period, most of the handling of data is done manually. And data mining and data analytics are really in their infancy. And just to go back to that manual handling of data, what I mean here is that the collection and aggregation, the generation of insights and patterns from data is not yet automated. Most of this is people doing this manually with hands-on keyboards work. The age of databases takes place from the 1980s to the 1990s. The two main takeaways here are really tools. And those include Relational Database Management Systems, or RDBMS, and SQL, or Structured Query Language. Now again, remember, 10 miles wide, 1 inch deep. You don't need to know what SQL is, but in short, this is a programming language that helps folks extract information from databases. That's just a little bit of supplemental knowledge for you. The age of the internet takes place in the 1990s to the aughts. Again, just as we saw with this same period in AI, this is the rise of the consumer internet, and terms such as big data and data mining gain currency during this period. From the aughts to the 2010s, we have the emergence of data science. There's an increase in data-driven decision-making. Again, that's extracting knowledge from data. Once we have data, we can make data-driven or evidence-based decisions. The two main takeaways for this period: number one, in the very, very early aughts, in 2001, William Cleveland proposed expanding statistical methods to include data computation. So here we get the application of statistics to data, doing data work. This really helps individuals to take advantage of the massive amounts of data that are being created by the consumer internet. The other main event is Hadoop in 2006. This is open source software that helps folks store data and run applications. And Hadoop in particular helped increase storage capacity and processing of big data. Finally, some current trends that you need to know about. The current trends period begins in the 2010s and continues to the present. It's during this period that data science folks begin leveraging statistical methods and machine learning to extract knowledge from data. We begin getting machine-generated data, and here machine-generated is referring to sensors that are picking up data from the environment, for example. We also see during this period the growth of real-time analytics, meaning that we have machines and sensors all around the world in certain environments that are collecting and processing data and then creating with that data dashboards that allow folks all over the world to know what's happening in real time. And it's all of these developments together that help advance the need for more advanced processing or faster compute. We have more data, we need more information from this data in real time. This means that we need to be able to process all of this data much faster. Finally, we're going to conclude with looking at the engines of growth for artificial intelligence. And there are 9 of these altogether. These are all different types of technology that begin leveraging data science and are being incorporated, built into AI systems. Mobile devices are important for a number of reasons. With the rise of the consumer internet, individuals begin carrying these computers in their pockets, these mobile devices, and because individuals are constantly using their mobile phones, they continue generating data. Again, companies want this data so that they can have more information about their consumers. With this information, they can make better choices with regards to serving up advertisements, for example. So the rise of the consumer internet, the rise of mobile devices, the massive increase in the amount of data that's being generated, this all helps lend itself to the creation and utility of artificial intelligence. Similarly, it's not just you interacting with your phone that's producing data. In the typical smartphone today, there are well over a dozen different sensors, and these sensors are also picking up and generating data on their own. The metaverse is a virtual space for interaction and business. This is an underdeveloped area, but if artificial intelligence and technology continues to advance, we can certainly see this being an important space for interaction in the future. Cloud computing is important because it provides opportunities for on-demand, scalable infrastructure. Individuals and organizations no longer need to purchase their own equipment and hire a team of IT folks to service and maintain that equipment. Instead, they can use on-demand, scalable infrastructure that's provided by places such as AWS, Microsoft Azure, and Google Cloud. Computer vision, again, this is an exciting area of artificial intelligence and allows computers to process visual inputs. Augmented reality or virtual reality, also known as AR and VR. These are also promising areas for artificial intelligence. An example of augmented reality is Pokemon Go, if anyone remembers playing that in the early period of COVID-19. And virtual reality, at least as far as gaming is concerned, has become quite popular. The Internet of Things, or IoT, this is internet-connected devices and sensors. And again, when it comes to the generation of data out in the environment, having internet-connected sensors that are collecting and generating data in real time is important for getting real-time data analytics. Privacy-enhancing technologies are allowing data scientists and AI engineers to work with massive data sets while preserving and enhancing the privacy of the individuals whose data they are working on. Privacy-enhancing technologies are also endearingly referred to as pets. And as it looks, these provide the ability to process PII, or personally identifiable information, and preserve the privacy of the data subjects. We're going to see that acronym a lot throughout this course, PII. Again, that stands for personally identifiable information. And I believe in Domain 5, there's a lecture devoted just to privacy-enhancing technologies. So we'll talk more about that soon. Social media, together with mobile devices, has increased the amount of data available for processing. And this is really important data for a number of different organizations. Data includes personal preferences, habits, lifestyle, and consumption patterns. And finally, blockchain. Again, this is a technology that may be, if not underdeveloped, at least underutilized at the moment. It's most commonly associated with the cryptocurrency trend. And if you're not familiar with blockchain, you can think of it as an append-only transaction log. In this lecture, we have gone over a brief overview of the history of data science. You need to remember that there are 5 key periods here: foundations, age of databases, age of the internet, emergence, and current trends. You need to remember the decades for each of these periods, as well as the main events and takeaways that we went over. You also need to remember the different engines of growth that we went over just a few moments ago.